Stefan Harbin here, PA at irondpc.com, bringing you a very cool literature review here by Hill and Williams, Meat Intake and the Dose of Vitamin B3 Nicotinamide. And it really is kind of like a bit of a history lesson. It really goes through the mechanisms, and it really goes through why do humans develop diseases in the first place, both acute, chronic, and autoimmune. And it really ties all back to meat. They go on to say that meat and nicotinamide intake was high during hunter-gatherer times. Intake then fell, and variances increased during and after Neolithic agricultural revolution. Health, height, and IQ deteriorated. So low dietary doses are buffered by welcoming gut symbionts and tuberculosis that can supply nicotinamide, but this co-evolved homeostatic metagenomic strategy risks dysbiosis and impaired resistance to pathogens. So it's very interesting that they're suggesting here that tuberculosis may have been actually a symbiont. And we're not talking about the movie, the Carnage movie. Maybe we are. Essentially, I guess tuberculosis can supply nicotinamide in certain times. But how this applies to us in the current modern age is we're not exposed to so many of these helminths, so basically parasites and infections like tuberculosis. So we develop often a hyperactive immune response to things. Vitamin B3 deficiency may now be common among the poor billions on a low-meat diet. Disease transitions to non-communicable inflammatory disorders, but longer lives, may be driven by positive meat transitions. High doses of nicotinamide lead to reduced regulatory T cells and immune tolerance, loss of no longer needed symbiotic old friends, compounds immunological overreactivity to cause allergic and autoimmune diseases. Inhibition of nicotinamide adenine dinucleotide consumers and loss of methyl groups as production of toxins may cause cancers, metabolic toxicity, or neurodegeneration. An optimal dosage of vitamin B3 could lead to better health, but such a preventive approach needs more equitable meat distribution. So, let's see how they talk about here. Really, it goes about NADH, which you're going to find NAD not in the supplements that Dr. David Sinclair sells with True Niagen, but you're going to find it in meat, beef, elk, beef liver, bison spleen, all of that. You're going to find NAD in those, and you're not going to find it in your plant-based proteins. Much has been written about modern maladaptions relative to our long hunter-gatherer days. These mismatches usually concentrate on loss of fiber or excess sugar or fructose or gluten in recent affluent diets. We argue that a high risk of too little nicotinamide may be the most important difference between diets in the past 10,000 years and those in the Paleolithic. During that long time, as we evolved and co-evolved, much of our nutrigenome, microbiome, or meat cultures, variances were usually feasts or famines, or fatal, as meat then provided most of the calories, rather than chronic shortages over lifetimes. The first Neolithic agricultural revolution and the second Green Revolution 50 years ago may have, as an unintended consequence, reduced meat and micronutrients for those in poverty. And I would go so far as to suggest that, we're not poor in the US, but we have so many other options outside of meat. We can go get the pizza at Domino's, which has a couple pepperonis on it. Most of it is gluten, right? We can go to McDonald's. We can fill up on a lot of soda there and French fries and bread and a little bit of meat, of course. So we have all these options outside of meat. And we're not a poor society. We have the option of buying meat. It's cheap. I mean, it may not be a top quality meat. It's not going to be your grass-finished, grass-raised meat, but it's going to be meat. And I think meat is better than nothing, or better than potato chips. let's look at the chart here on nicotinamide concentrations in animal products. Red meat 100, chicken 70, fish 50, peanuts 100, that's impressive. Coffee 50, oh, that makes me feel happy about drinking coffee. Beans, very low quality, so your pea protein just doesn't have the nicotinamide you need. Barley, no. Wheat, absolutely not. Rice, nothing. Soybean, nope. Vegetables, absolutely not. So you're not getting nicotinamide if your diet is based right here. Brewer's yeast, that's an interesting one. I use that in my mead when I ferment that. Meatification of the diet doubled meat intake in the United Kingdom between 1850 and 1960, and has overall increased by twofold average intake from 20 to 40 kilogram per annum per person in 1960 to double that in 2010, as is nicotinamide intake, and is predicted to rise to 50 kilogram per annum. The extremes are striking at 120 kilogram per annum per person as an average in many rich countries, who also obtain nicotinamide as mandated supplements and manufacture additives, but 20 kilogram per annum per person in many poor countries, with many individuals eating negligible amounts that have to affect a society's health and industriousness. Such individuals must be at risk of the classic meat deficiency disorder, particularly when a poor monophagic cereal diet, usually maize, known as pellagra. Pellagrans can be a diagnostic rash. We've seen these in pictures in our medical training. We don't really see that very often. But what this article here is suggesting is that pellagra is a spectrum, and we can see it present itself in more so than just a pellagra rash that we learned in medical school. We see it potentially affecting a whole host of diseases. Hypothesis. We will argue that nobody ever systemically checked that pellagra was eliminated globally. Dietary supplementation mainly happened in rich countries. Pellagra may be common and misdiagnosed, masquerading as an environmental enteropathy, poor cognition, eczema, or general ill health, and a lack of well-being or poor homeostasis when under environmental stress with shortened lives. We will also argue that environmental insults from trauma, hypoxia, toxins, stress, or mutations, such as in mitochondrial or DNA repair genes, may require either lifetime or temporary higher doses than normally recommended. And this is where Dr. David Sinclair's product, the NAD Plus booster, comes into play. I like to use this in some conditions, especially in ex-vegans or recovering vegetarian-based patients who develop an autoimmune condition. They may benefit from Dr. Sinclair's product. Controversially, we suggest that many people in rich countries may be on too high a dose. A hypervitaminosis B3 state may be common and, like pellagra, have a wide phenotype that includes the metabolic syndrome, several cancers, and some degenerative or neurobehavioral disorders. Furthermore, we propose that the transition from diseases of poverty to diseases of affluence is due to switching the dose of meat nicotinamide too fast and too far. The most recent version of the hygiene hypothesis concentrates on reductions in symbiotic commensal biome diversity required early in development, not cleanliness during childhood and common pathogens. We will discuss how a biochemical switch away from the need to produce nicotinamide in-house from tryptophan and the related reduced metabolic need for gut symbionts and tuberculosis on a better diet so that they are no longer welcomed by the immune system is a more plausible explanation for the loss of microbial old friends. This switch of microbiomes reduces tolerogenic instruction to the immune system, further encouraging it to overreact to otherwise irrelevant foreign proteins or self-proteins. So this explains perhaps why we're seeing so much autoimmune disease in this current age. People aren't dying from tuberculosis or Helminth parasite infections. They're dying or suffering with autoimmune conditions. Biochemical background. So this goes into a bit of a complicated discussion on how NAD works in different metabolic pathways. So we're going to skip a bit of this. It's a bit too involved. Let's see. Very interesting how NAD works to fight off infections. Some hindgut symbionts produce nicotinic acid that they share, as does TB. We have argued that when meat sources are good and shortages short-lived, TB acts as a symbiont farmed for its nicotinamide. The relationship with classic pathogens is different. Many have evolved to be consumers of host NAD, and many of their toxins directly affect NAD consumer pathways. If the host is moderately deficient in nicotinamide NAD, in the first place, they will be less resilient. If severe, the pathogen may not have enough to survive, perhaps explaining the paradoxical relationship between nutrition and infection when very poor nutrition can be protective. How fascinating. But this does explain really the fundamental reason why people get sick. It could be NAD deficiency, which is the most basic cellular, when you're looking at the basic level of what a human is, it's the mitochondria, the powerhouse, right? It's NAD. And if we have a dysfunction of these, we're less resilient to infection. We're less resilient to toxins, environmental pollutants. We're just really, maybe even psychologically less resilient. NAD is so fundamental to human physiology, and not just human physiology. NAD is pretty much critical to every living being. If you look at a bacteria, they're using NAD, right? NAD has been around for millennia. Pathways, over and under nutrition, are bad for health, as demonstrated by the Wheeler curves for height, weight, and mortality. We propose that they share pathways that intersect with symbionts. Buffering poor diet both relate to nicotinamide metabolism. Butyrate and nicotinic acid are generated by gut symbionts that include lactobacillus and bifidobacter and clostridia that ferment fiber and otherwise indigestible complex carbohydrates and are in high concentration in the colon. Butyrate is an endogenous ligand active on the G protein, nicotinic acid receptor, expressed on macrophages, dendritic and epithelial cells, and adipocytes. This sends non-redundant signals via interleukins that affect T cell differentiation, favoring Tregs over helper T cells when diet is poor, as does nicotinamide from diet when it is rich. This signal from the niacin receptor reduces inflammation and carcinogenesis, and has independently been proposed as a factor in mediating and perhaps moderating diet and disease transitions. There is much supportive evidence of differences between microbiome on rich, poor, and traditional hunter-gatherer diets, and that the tryptophan pathway is involved in states of malnutrition, or rare but illustrative genetic defects that affect nutrition. Reliance on the microbiome could mean that those on a poor diet are at risk of broad-spectrum antibiotics temporarily eliminating symbionts and triggering clinical nicotinamide deficiency. Wait, hold on. So they're saying that hunter-gatherer diets that relied on tryptophan, which you can get that from carbohydrates, that these people who rely more on a carbohydrate-based diet, when they get hit with broad-spectrum antibiotics and these symbionts, these gut bacteria, are destroyed, these people can get sick afterwards. Fascinating. Although many factors have been shown to alter traffic in the de novo pathway, particularly infectious disease, it is important to remember that its primary purpose is the production of nicotinamide NAD from tryptophan when the diet is inadequate. The consequences are immune tolerance to some useful symbionts. Immune tolerance is mediated by an effect on the balance between Tregs and T17 helper cells, also the target for steroids and many modern immune therapies or artificial infection with helminths. Oh. Vitamin D and A from sun, meat, and fish. Nicotinamide diet, high. Xenobiotics, poisons. Wow, what an interesting diagram. They really put a lot of thought into this. Am I frozen? I am frozen. Now we're going to get into a couple more charts, kind of like historical graphs. Let's float on top here. So they gathered data from a couple different studies. And really, obviously, they're drawing correlations here, but a lot of these are very interesting. In summary and in round terms, in the United Kingdom, between 1850 and 1900, death rates per million with both sexes combined are as follows. For TB, before any treatment, halved from 7,000 to 3,500. For dysentery, fell by 9/10, from 150 to 15, whereas cancer, before much effect from smoking, at least in women, increased by 2.5-fold from 700 to 700, and diabetes increased 4-fold from 15 to 200. The incidence of Parkinson's disease rose markedly, having only been described in 1817. During this period, meat intake almost doubled. Measures of cognitive and physical health, such as literacy rate, increased, as did height. Contemporary data comparing these conditions with average meat intake across countries support these correlations. More specifically, the reduction in deaths from diarrhea between 1850 and 1950 in the United Kingdom trended with the rise in meat intake. So here we have the graph of diarrhea plotted against meat intake in the United Kingdom. We can see meat intake increasing and then diarrhea decreasing. Now, is this from really meat or is it from enhanced plumbing? What happened between 1850 and 1950? I don't really know what was happening in the United Kingdom. But we didn't have better treatments back then for diarrhea conditions. I mean, maybe the IV was invented for IV fluids. Who knows? Let's see if they have any better ones here. Literacy rates. Oh, that's an interesting. Meat consumption. Let's see. Kilogram per capita going up over time. Percentile illiterate going down. Okay. Maybe there were just better teaching methods? Probably not. Let's see. I think they were still working as indentured servants at that time. What else do we have here? IQ correlates with meat consumption across countries. So the IQ plotted against meat consumption in the contemporary world across nations. So we have measured IQs in 2006. We have kilograms of meat consumed per capita going up. Okay. Meat consumption in heights in boys in Christchurch. Yeah, we definitely know that eating better calories or higher quality calories is going to help with growth. So meat being one of those top quality calories. What's this? Tuberculosis plotted against meat consumption in the United Kingdom before there was any drug therapy. Here we can see meat consumption in kilograms per capita up, and deaths per millions coming down from tuberculosis. Probably one of the most significant graphs I've seen here. Because I can't imagine they had better, like, you know, if we believe in masks preventing disease or sanitation, you know, people were still coughing on each other in the United Kingdom. So we have to think how it went away. Maybe it was meat. Let's see. Diabetes deaths rose between 1850 and 1950 and correlated with meat intake, as they do across the world today. Diabetes body has meat consumption. So diabetes, meat consumption per kilogram per capita increasing, and then UK diabetes rates also increasing. But as we know, as we discussed in other lectures, that meat is typically never looked at in isolation in these studies. It's always along with carbohydrates. Typically people who eat meat also smoke more. So there's a lot of confounding factors there. That's a tricky one to look at always. UK cancer deaths and meat consumption in England and Wales, 1840 to 1895. So cancer increasing along with meat increasing. That's where we get a lot of the vegan studies saying that meat causes cancer. Comparison of meat consumption and estimated deaths per 100,000 from neoplasms. Here are meat. High. Estimated deaths from neoplasms. Total number of deaths registered for paralysis agitans and meat consumption in England. Oh, Parkinson's. I never heard of it called paralysis agitans. The allergy epidemic, 1870 till now. The recent rise and exact timing of the rise in hay fever and allergic autoimmune disease are less well documented numerically. Although the facts are not in dispute, an average meat intake has also doubled again between 1960 and now, so if they were very strong correlations would be obtained. Apart from a very few references in ancient literature, allergy first in the form of hay fever was first described in the mid-19th century, exactly at the time the TB epidemic was abating in both the United Kingdom and in the United States. Observers at the time described these conditions and noted that they were on the increase, to begin with, among the fashionably wealthy. Allergic disease had been unknown in previous generations, much as they are still unknown in poor African villages today. Increases are being recorded in countries that are getting richer or have had the economic benefits of European reunification. Proximate triggers such as grass and ragweed pollen were noted early on, but they do not contain new antigens, even if some became more prevalent. Rather, paradoxically, avoiding the allergen can make matters worse, as recently demonstrated for peanut allergy. So treating the proximate allergen as the actual or preventable cause is problematic. The ultimate cause of the epidemic, allergens, has been linked by others to the decline in tuberculosis, using evidence from BCG vaccination and inverse associations with tuberculin responses or other infections. Current maps of the incidence of infections such as helminths, which are parasites, and TB are diametrically opposed to incidences of allergic and autoimmune diseases. Reduction in helminth infection, as with TB, is also associated with relief from poverty and poor diet, with limited overall impact of antibiotics, at least at a population level. As animal parasites, their interaction with host nicotinamide status and biochemistry could be either positive or negative, but has not been studied. Kind of like the inverse relationship here, because the autoimmune disorders in the Americas and Europe's, and not in Africa, Brazil. Helminth infestation, we can see, parasite infections pretty high in these countries here where they don't have autoimmune conditions. A reasonable proposition as to the timing of the allergy epidemic is the Northwest is shown. Not only numbers, but also diversity of autoimmune diseases continues to radiate. Links with NAD metabolism through CD38 and allergen pollen NADPH oxidase have been made. The latter links to oxidative stress and T cell imbalance that could cause allergic disease, but only if TREGs were unbalanced in the first place prior to exposure to the immediate extrinsic signal. High tryptophan levels and low IDO activity, I didn't provide what the acronym means, has also been recorded in allergic disease with whether asthma or food allergies. In addition, the modern outbreak of depression appears, despite cross-cultural issues, to be a feature of disease of affluence and may influence many of the others and can be clearly related to disturbed tryptophan and serotonin pathways. The commonest cause of infertility, polycystic ovarian syndrome, is also far commoner in developed economies and has been related to the metabolic syndrome and autoimmune disease. This is relevant to the argument we make in our companion article about increasing infertility in high meat economies. Questions. We now ask a series of questions to further explore and try to convince readers that the dose of vitamin B3 is a significant health issue and that deficiencies and perhaps excesses are commoner than is usually supposed. Was pellagra conquered, or is it still endemic in some poor meat areas? The short answer is that nobody has checked systematically at a clinical or biochemical level. Interesting. Was pellagra conquered, or is it still a common cause of poor intellectual development or premature aging, including dementia? Before the biochemistry and treatment of pellagra was sorted out in the 1940s, it was pointed out that the lack of meat in diet had profound effects on health and height, and clinical manifestations went outside the classic pellagra phenotype. This view was criticized by vegetarian groups, including Gandhi. We now realize that there is a world difference between an economically driven, poor, monophagic vegetarian diet and a voluntary vegetarian diet of good quality that often includes some animal products and supplements, so the latter has few dangers and some advantages. During the American and early European epidemics of pellagra, often in families whose other members diagnosed, there was many with poor physical and mental development. Indeed, a high proportion of both blacks and white trash in southern states may have been affected. The average IQ of Confederate recruits were in the moron category, and that was not true for the richer Union recruits. The correlations we now see between IQ literacy and meat intake may represent nicotinamide deficiency. The dramatic changes in IQ known as the Flynn effect as countries became more prosperous may reflect increased nicotinamide intake and a better brain in the first place, more capable of learning from a better educational system and less prone to dementia. Indeed, there is already considerable evidence that nicotinamide could prevent or benefit Alzheimer's disease and has a role in serious neuropsychiatric diseases such as schizophrenia and post-traumatic dementia. Increased longevity could also represent improving nicotinamide dosage. This is supported by pellagra causing premature aging and dementia, and evidence that NAD levels fall with age, given that NAD consumers are largely responsible for aging and repair mechanisms. Yes, it is a longevity molecule. Morons, I can't get over that. The Confederates were in the moron IQ level. Yes. Is there a strict recommendation dose of nicotinamide? Or do some people with some genetic mutations require a personalized dosage? Yes, of course, you need to personalize it based off symptoms, based off how well you're doing. All right, when you have autoimmune conditions, you need to look at your basic metabolic reserves, NAD being the crucial one. What's this about Creutzfeldt Jakob? Many diseases where the environmental trigger is not known may have an NAD deficient endophenotype. This is suggested by the extraordinarily varied phenotype of pellagra, where a wide range of dementias and neuropsychiatric conditions were described, including mimics of Creutzfeldt-Jakob disease, so prion disease, Parkinson's disease, motor neuron disease, and multiple sclerosis, and cerebellar syndromes, alongside migraine and epilepsy. Evidence for such a deficit is already strong for some, such as prion disease, where this is phenotypic overlap with pellagra. NAD deficiency. Was the change in dosage of nicotinamide the transition factor converting diseases of poverty to diseases of affluence? Did this lead to the loss of old friends such as TB, allowing a poorly educated immune system to become overreactive? They respond, nicotinamide adenine dinucleotide status is probably crucial to the poor resistance to pathogens seen in poor countries. Many pathogens or their toxins target the host's NAD system by disrupting NAD consumer pathways or by secreting NAD glycohydrolase, break down that host's NAD levels. We have also argued that TB and some gut symbionts originally co-evolved to supply nicotinic acid. Such symbionts became dysbiotic and behave as pathogens when the diet is low in meat for protracted periods of time, or if driven to mutate using antibiotics. Nicotinamide was the first anti-tuberculosis antibiotic discovered. The largely spontaneous disappearance of TB as countries and diets become richer becomes less of a mystery and is less likely to be related to better hygiene. There are indeed good examples of improving sanitation, improving waterborne infections such as cholera, but having little impact on other infections until diet and particularly meat intake is addressed. In one famous example, improved sanitation caused an increase in mortality as the increased rents led to a decline in food quality. A famous other example was rebuilding barracks, to no effect on TB rates until the meat intake was increased, and of course, TB becomes rampant during many famines. It is notable that TB sanatoria were not closed but were transformed into sanatoria for allergies that first became a problem for the rich on rich diets. And nicotinamide switch towards the evolutionary norm of high meat diet could be responsible for the switch from TB and other chronic infections now co-evolved to affect the development of the immune system, to a poorly educated, overactive immune system responding normally to innocuous antigens. The biochemical nature of the switch was outlined earlier. The speed at which the switch is turned could be important, with the highest risk within a lifetime or a generation or two for diseases of affluence. Therefore, immune adaptations and a different starting point of the microbiome may occur compatible with little evidence that hunter-gatherers had autoimmune allergic disease, trauma leading to shorter lifespans that may have spared them later onset diseases. The spread and origin of the obesity epidemic is interesting regarding this as a modern maps of the epidemic and obesity, diabetes, and stroke belts are strikingly similar to maps of pellagra a century ago, suggesting that the switch can manifest over several generations, raising future discussion over thrifty, and in other contexts, non-thrifty, nicotinoid-related genotypes and phenotypes, and developmental plasticity having effects on later disease compatible with the known involvement of nicotinamide, butyrate, and methyl groups in epigenetic modifications. Yeah, the South has a lot of diabetes. Over and above a rash of immune diseases, has the dose of nicotinamide become so high that there is an unrecognized hypervitaminosis B3? That's a great question. Nicotinamide is widely viewed as having little serious toxicity, at least in the short term. We suggested nicotinamide toxicity as a causative factor for Parkinson's disease, the metabolic syndrome, and some cancers, based on direct or indirect measure of high levels of NNMT. Too low a dose and nicotinamide can be protective for cancers and Parkinson's. So we're proposing a double-edged dosage effect. As an inducible enzyme, the logical culprit for NNMT overexpression is the dose of nicotinamide, even if other factors such as caloric restriction, stress, and exercise play their part. Background genetic variation in levels may reflect exposure in earlier generations. Certainly, this is true of species as the enzyme is not expressed in herbivores. Our original hypothesis for Parkinson's disease was that N-methylnicotinamide resembled the dopaminergic toxin, NPTP, and so may be toxic at high levels even though beneficial at lower levels. Part of the jigsaw may be that nicotinamide dose upsets the microbiome and in turn contributes to the proteotoxicity and affects the nicotinic acid receptor. Other metabolites may be nephrotoxic. I don't think you can have too much of meat. As dietary manipulations go, reducing the dosage would be easy as supplements could be reduced in rich countries with no behavioral change necessary. Reducing meat intake may also be fairly painless, even if nicotinamide like nicotine has some addictive qualities, as is now practiced by the healthy wealthy. Increasing the dose to those really at risk would be relatively easy and not very expensive if talking about supplements or biofortification of crops. More meat, however, is not as easy as it is expensive, but may be necessary if nicotinamide is the only factor necessary or is actually dangerous on its own, as it is a drain on methyl groups. Redistributing meat from those eating too much to eating those too little would improve the health of group groups. Oh, is that communism? Conclusions. Hypo, so subclinical misdiagnosed pellagra, and hypervitaminosis B3, nicotinamide overload, may both be far commoner than has been supposed and have equally wide phenotypes transcending many conventional, clinically convenient disease categories. The transition from populations of low to high intake may explain the extraordinary shifts within single generations from Roundtree's stunted life with chronic diarrheal infections and TB and disproportionately high deaths from pathogens to non-communicable diseases. Non-communicable diseases include multiple and expanding allergic, inflammatory, and autoimmune diseases, along with the metabolic syndrome, many cancers, and neuropsychiatric diseases, but in the context of longer lives. Geography per se has little to do with these phenomena, as they track much more closely with poverty and affluence, and therefore meat intake. Even the term tropical diseases is a misnomer, as many of these infections were common in Victorian England and the pellagra-prone Southeast American states a century ago. Much current effort in rich countries is for personalized precision and genetic medicine, usually for people who already have contracted often rare diseases. Understanding these disease transitions may be less eye-catching, but offers more potential for low-tech population-based preventive approaches. Personalized NAD-related medicine can be nutritional, rather than glitzy genetic manipulation, as several genetic diseases may be due to the genes that originally evolved at times of nicotinamide luxury or thrift. Predicted tidal waves of dementia may be preventable. Too little nicotinamide, as may some neuropsychiatric diseases, diabetes and metabolic syndrome, some cancers and Parkinson's disease, too much. Nicotinamide overload may not work alone, but with other hypervitaminosis or deficiency states. One example might be nicotinamide but low vitamin D in MS, compatible with the known epidemiology and genetics implicating little sun, but a lot of meat, and known involvement of the de novo pathway. It will have been partly iatrogenic if increasing the dose of nicotinamide with supplements also affects caloric hunger and obesity levels and other diseases where NNMT induction have been demonstrated. Phenotypic diversity may be explained by individual variation, whether genetic or from previous environmental exposure, and the different sensitivity of cell types to NAD upsets. Homeostatic responses that fail or have longer-term price, whether autocarnivory, the use of symbionts, or inflammatory or cancerous tissue that overexpress NMT, or NAD consumer enzyme, or induction of IDO, may also be responsible for clinical heterogeneity. New phenotypes may be occurring. Predicted Armageddon, as antibiotics rapidly become ineffective from multi-drug resistance, may be due to not dealing with the fundamental nutritional cause. Antibiotics are a strategy that encourages mutations and emergent pathogens. Better NAD status will reduce the need for broad-spectrum antibiotics by reducing virulence. Reliance on symbionts, including TB, also means that antibiotic use could trigger pellagra that will probably not be recognized or treated. When symbionts are relied on too heavily, blooming in the gut can lead to dysbiosis and pathogen evolution relevant to environmental enteropathy that may be a new version of pellagra. Very interesting. Meat gluts. Learning from history could help developing countries avoid the trap of the Western diet with lack of exercise and meat intake overshoots. There is little sign of such wisdom currently, as the double burden in developing countries reflects a breakdown in the Engel law, whereby poor to moderate wealth transitions classically increase the absolute but not the proportional amounts of income spent on food, increasing meat intake. This economic transition is now more likely to lead to increased empty calories. Yep. Wow. This is probably the most thought-provoking journal article I've read anywhere. In all the YouTube videos I've done here, I've never read one like this before. It just puts together disease so perfectly. The amount of research they put into this is incredible too. How many references? They just keep on going. The references keep going. Oh my gosh, you're gonna make my computer crash. 372 references. This must have taken them forever. I can't believe we read this whole thing. Who are these people? A Brit. Adrian C. Williams and Lisa J. Hill. Oh, he writes a lot. Let's look him up on Instagram. Maybe he has an Instagram. Williams. Let's look him up on Instagram. Insta. We gotta have an Instagram. Everyone does. Come on. Adrian C. Williams. Let's see if we can find him on the ING. Where's he at? Oof, this is a long video. I'm gonna make my computer crash. What was his name? Adrian Williams. Adrian Williams. Hello? No. has one. Anyway, hat tip to the authors of this. This was amazing. They don't teach you this in medical training. How meat deficiency is probably the underlying root cause of most disease. I don't know if I agree with them so much on nicotinamide excess. So, you're not going to get that from eating too much meat. I don't think that's possible. I still think disease states is from everything else that's consumed. If you just look at meat in isolation, I mean, that would be a great study. But that's not going to happen. Now, adding niacin to everything, yeah, maybe that could potentially be too much. They put it in an additive for a lot of things. Honestly, I don't think it could cause too many problems either. I like True Niagen, especially as a supplement. I just don't agree with them on having too much NAD. I think, most people are deficient in it. Anyway, I hope you liked this lecture. That was a long one. We'll end it here.